Hi, today I'll be discussing about the importance of chemical industry consulting. So I want to show one big idea. Countries do not become powerful just because they have natural resources, land or strong armies. They become powerful because they know how to turn raw materials into useful products at large scale. And my main argument is this. In today's world, especially in the chemical industry, one of the most important people in the process is the consultant who can connect science, business and industry. If you look at history, the strongest nations were usually the ones that could transform materials better than others. They could take rocks into metals, plants into textiles, and molecules into money. So, chemistry sits at the center of the story because chemistry is really the science of transformation. A molecule is just a small unit of matter, like a building block of a chemical substance. But science alone is not enough. Someone also has to know that knowledge and translate it from laboratory into the real life. That is where this invincible function comes in. I call it the boundary spanning consultant. This is someone who can move between worlds. They can speak to scientists, they can speak to engineers, they can speak to investors, managers, and policymakers. It's a boundary spanning person is simply someone who connects groups that normally do not speak the same language, like scientific language, economic language. Without that kind of person, a great discovery may be stuck in a paper or in a laboratory or in a pilot unit, and they would never become a real industrial power. Let me show you the logic of today's talk. First, I will walk through the history and show that power usually follows materials and importantly industrial process. Second, I will explain where many countries and companies fail. There's a gap between invention and full commercial success. Third, I will show why electrification and decarbonization make this challenge even important today. Electrification means replacing fossil fuel based energy with electricity, and decarbonization means reducing carbon emissions, especially carbon dioxide. And finally, I will explain why consulting in chemical industry is not just important, it's really strategic going. There is a pattern in history. Different periods of power were built on different materials. The Dutch rose through trade and processing. Britain rose through coal, iron, and industrial system. The United States rose through oil and petrochemicals. And China is rising through scale, material processing, batteries, and manufacturing control. So the lesson is simple. Power does not simply come from owning resources. It is coming from the knowledge on how to process them better than everyone else into more value-added materials. Let's start with Dutch. The Dutch Golden Age was not mainly about inventing new things. It was doing process better than others. Spain was bringing silver from America, but Dutch were building trade systems, shipping systems, and storage systems and refining systems. They were not just moving goods, they were improving them, organizing them, and making more money from the trade. You can almost think of Dutch as an early process expert. They took raw spices and other goods, then refined, preserved, packaged, and sold them in a really smart way. Refined means improving a raw material by removing unwanted parts or making it more useful. Preserving means keeping it stable so it lasts longer. Their important lesson was that real money is not often in digging something out of the ground. The real money is in transforming it into something more valuable. Now let's move to Britain. Britain became powerful through coal, but coal itself was not the full story, right? People already knew coal existed, but what changed was the process. One major breakthrough was coking. Coking means heating coal without air, so it turns into a cleaner carbon rich fuel called coke. That made it much better for making iron. Once Britain could do that well, it could make more machines, more railways, more tools, and more industrial infrastructure. But Britain's rise was not just about chemistry, it was also about finance, empire, and control of global flows. Finance here means the ability to raise and manage money for large projects and importantly war. Britain also recognized and reorganized colonies like India for that they supplied raw materials instead of finished goods. Simply speaking, Britain built a system where materials, money, and political power all work together. That is why I say power is not just about one invention. It is about the whole system around it. Now we come to United States. The American century was built on oil, but again, the key was not just owning oil. The process was the important part. The key was processing it better. One major breakthrough was catalytic cracking. Catalytic cracking is refining process that breaks oil molecules into lighter and more useful ones like gasoline. And here we are using heat and catalyst. And in this case, catalyst is a material that helps a chemical reaction happen faster or better without being used up in a reaction. And this gave the United States a huge and industrial military advantage. The United States did something important also. It connected oil to global finance. In simple words, oil was not just a fuel, it became part of world's money system. That means the United States was not only controlling a raw material, it and not only controlling its refining also, it was also shaping how the world traded and paid for that material. So once again, we see the same pattern. Technical power becomes even stronger when it's translated into business and political power. This is also where modern chemical consulting becomes easier to see. Companies and advisory groups help move discoveries out of universities and labs and into real factories. Commercialization simply means turning an idea or invention into something that can be sold and used in market. Firms like Arthur D. Little helped companies scale materials like plastic, synthetic rubber, and nylon. Scale means producing something in a much larger quantities, reliably and profitably. This is where the translator roles become formal and professional. Now let's look at China. China's rise is very important modern example because it shows that invention is not only the source of power. China became strong by mastering scale and process control. Process control means keeping production conditions stable and precise so that the quality remains consistent. China built huge strength in manufacturing and in processing of key materials. That matters because in modern world, the winner is often the country that can make difficult materials reliably, cheaply, and importantly at a very large scale. So, rare earths are a really good example. These are a group of elements used in magnets, electronics, lasers, and other advanced technologies. The most important part is they're hard to separate and purify. Separation means taking a mixed material and isolating the exact chemical you need, and purify means cleaning it enough for high performance use. So the real advantage is not just finding the material, the real advantage is able to process it well. So that's where the chemical engineering and the process know-how becomes the geopolitical power. The same thing is true for batteries. In electric vehicles, success is not just about designing the car. It is about who controls the battery materials, the battery manufacturing. Here's where terms like cathode, anode, NFM, LFP can sound technical. So let me simplify them. Cathode and anode are two main sites inside a battery where the energy moves during charging and use. NCM is a battery chemistry based on nickel, cobalt, and manganese. LFP is lithium iron phosphate. The country that can make these materials with the right particle size, the right purity, and right consistency at a huge scale have a major advantage. So far, I have shown how nations rise. Now we need to ask, how do they fall behind? Very often they fall behind not because they stop having smart scientists. They fall behind because they cannot turn the invention into large-scale industrial success. In other words, they can still discover things, but they cannot build competitive factories, supply chains, markets around these innovative discoveries. That's where people call the valley of death. The valley of death is a difficult stage between successful lab result and a fully working commercial product or a plant. A commercial plant means a real industry facility that operates at full scale and makes money. Many ideas die in this stage. They do not die because the science is fake, they die because scaling changes the problem completely. Let's make that very simple. A chemist see a 99% yield in a flask and think, the problem is solved. Yield means how much useful product you get from the material you started with. But a CEO sees cost, payback time, planned risk, market demand, and uncertainty. And investors even see more risk. So the issue is not only does this reaction work, the issue is can this reaction work at an industrial scale, at an acceptable cost, with a stable quantity, and with a real customer. We have seen this kind of failure many times. Concorde was technically impressive but commercially weak. Kodak helped create digital photography but did not adapt fast enough. Blockbuster saw the digital change coming but they stayed trapped in the old business model. These cases show that failure is not always lacking innovation. It's not about always lacking innovation, but it is often about failing to translate this innovation into a new system that actually works in the market. The same problem exists at a larger strategic level. Sometimes leaders keep using older assumptions even after world has changed. That can happen in war, in politics, and in industry. A paradigm is just a way of thinking or a mental model for how world works. When a paradigm becomes old, people can make really serious mistakes. So the lesson here is, if the rules change and if you think still in the old way, you can fail very quickly. In chemical industry, this gap is especially painful. A process may work in the lab or pilot unit but fail in a real plant. So a pilot plant is a small test version of a huge factory used before the industrial scale. Why can it fall? Heat may move differently, mixing may change, impurities may build up, a catalyst may lose activity over time. It's called catalyst deactivation, which means the catalyst slowly stops working well. The chemistry will still be possible, but the economics will collapse. That's where consultants like me become valuable. The consultant helps translate between the laboratory results and the business metrics. They can ask, what will this cost at that scale? What risk will appear in the real operations? What product quality will the customer accept? What will energy and waste management do to the economics? So techno-economic analysis is a term used often here. It simply means the studying both the technical performance and the business performance together. So instead of, we are not just looking separately the technical performance and business performance, we are merging them together. So now let's move to the present and future. The 20th century was shaped by oil, but the 21st century is shaped by electrification, carbon pressure, and new feedstock. A feedstock is a raw material that you feed into a chemical process. So the transition is not just about changing the energy sources, it's about redesigning the entire chemical industry itself. That's why the challenge is so huge. In green translation, every country would benefit if all the countries would reduce emissions. But each country is tempted to delay if it thinks others will carry the cost. A stag hunt is one type of game where the best result comes from cooperation, but people still choose the safer, smaller option if they do not trust each other. That's where carbon tariff came. A carbon tariff is an extra cost based on import from places where carbon rules are weaker. CBAM, the Carbon Border Adjustment Mechanism, is European Union's version of that idea. It is meant to stop companies from gaining an unfair advantage by producing with higher emissions elsewhere. At the same time, China has built major strength in solar panels, batteries, rare earth processing, and green manufacturing systems. So, many countries now face a hard choice: depend on China for hardware of green transition, or rebuild their own industrial base. Who is likely to win in this new world? Usually, the winners will be countries and companies that think long term. They will be like thinking long term, they will be building process capability and learning fast and industrial scale. Process capability means the ability to run production well consistently and efficiently. That's why China is so strong and why highly specialized long-term firms like many in Germany's Mittelstand are interesting examples. The losers are likely to be trapped in short-term thinking, weak industrial capacity, or heavy dependence on old oil-based systems. Now we reach the core point. In this kind of world, consulting is not a side activity, it's become a strategic activity. The most valuable person is not the scientist, not the financier, not the policymaker. The most valuable person is often the one who connects all three of them. That's why a consultant with deep technical knowledge and a business understanding becomes so important. There are several reasons for this. The first is capital efficiency. Capital simply means the money invested in plants, equipment, and business growth. If $1 billion plant fails, that does not just hurt one company, it scares the investors away from the whole sector. Second is the speed. A country that moves faster from lab idea to factory often wins the market. Technology transfer means moving knowledge from one place, like a laboratory or a university, into real industrial use. The faster and better that transfer happens, the stronger the competitive position. The third is resilience. Resilience means the ability to handle shocks and recover. We saw that during the COVID. Supply chains can break suddenly. A supply chain is a network that moves material and products from one source to final user. Countries can rebuild production quickly, and these companies are more secure. Then there are what I call like certain hidden rules. There are like hidden rules like carbon rules, subsidy schemes, strategy signaling, and information gaps. Strategy signaling means sending actions or messages that show strength, weakness, seriousness, or intent. A good consultant can help companies and governments read those signals better and avoid bad decisions. If we look at history, we keep seeing this version of this consultant like translator roles. Sometimes it is a philosopher shaping knowledge. Sometimes it is a financial strategist helping state fund expansion. Sometimes it is an industrial advisor helping a company move from invention to market dominance. The names and settings will change, but the function is same. Someone connects ideas, systems, and execution. Execution in this regard means like actually getting something done in the real world, not just planning it. So, let me end with the main message. In the 20th century, power often belonged to someone who controlled the oil. But in the 21st century, power will belong to someone who can design, finance, and operate the new chemical system of the future, which is especially electrified and circular system. Circular means the system is designed to reuse the material instead of wasting them after one use. So it's like circular. The chemist alone cannot do that. The financier alone cannot do this. The policymaker alone cannot do this. It is the person who can connect all these worlds become the decisive factor. That's why I say chemical industry consultant is not just a service provider. They are the most important part of a hidden engine of a national sovereignty. Thank you very much. Roshan Tajidikla here.